Hello my dear students, welcome to Learn with UMVS channel. So today we are going to study the most important concept for the class 8, 9th and 10th standard students in chemistry part, where the students feel much difficult and understand how the bonding takes place in chemistry. So let us study about types of bondings. So before coming into the concept of types of bonding, we will study the classifications of elements. How? So if you take a periodic table, mainly we classify elements as metals and non-metals. There are metalloids also, but here we are going to study about metals and non-metals. So if I am speaking about metals, so metals are known for losing the electrons. So we can say metals will always lose electrons, whereas non-metals are meant for gaining the electrons. So based on the properties of losing and gaining the electrons, the bonding is classified. So mainly bondings are classified into two types, ionic and covalent. So before getting into the ionic and covalent bonding, let's study about some more thing about metals and non-metals. So we have a concept called as valence electrons. The meaning of valence electrons is the electrons present in the outermost shell of an atom. For suppose, if I say sodium, so for sodium, if I am writing electronic configuration, it's going to be 2, 8, 1. So the last one electron will speak about the valence electrons. So this valence electrons must be lost by the metal to get 8 as a valence electrons. So what is this 8 number? So in chemistry, 8 number will speak something called as octet rule. So every element in periodic table will struggle to get the 8 electrons as valence shell electrons. So this rule is called as octet rule. Same way non-metals also will struggle, either they will lose the electrons or they gain the electrons to ultimately become as valence electrons having 8 in the valence shell. So now metals will generally have 3 valence electrons. Basically either they have the type 1 as 2, 8, 1, or they have 2, 8, it might be different and valence electrons will end with 2 or they will end with 3. So these might be for the different atoms. Either they may end with 1 as a valence electron, either they may end with 2 as a valence electrons, either they may end as 3 with the valence electrons. Now let us come to the non-metals. So this non-metal, for example, we'll speak about the chlorine. So chlorine has an atomic number of 17. So if I am speaking about electronic configuration of chlorine, it becomes 2, 8, 7. So this 2, 8, 7, if you see properly, it requires one more electron to become a octet state of stability. See, what is this octet rule? So octet rule is something where every element in periodic table, they either gain the electrons, lose the electrons, they undergo reactions, they undergo some other things, all the different types of reactions. So ultimate aim of the octet rule for every element is to have 8 electrons in their valence shell. Or for first 5 elements, if we speak the first 5 elements, hydrogen, helium, lithium, beryllium and boron, the helium is the nearest electronic noble gas for them. So here for these atoms the octet rule doesn't verify. So we call that state as duplet state of stability. Okay, so here hydrogen have an atomic number of 1, whereas helium has 2. So hydrogen will need one more electron to become the state of helium. If I speak about lithium, the electronic configuration of lithium is 2, 1. So what does lithium will do? It will lose this electron. So it gets a state of duplet. Same way beryllium. So beryllium 2, 2. So it will lose these 2 electrons. Same way boron, it has 2, 3. It will lose this 3 electron. So you may ask, sir, why it is losing? It may get 5 more electrons to become stability of octet rule. If you speak about the nucleus, so this nucleus will have only 5 protons. So that nucleus cannot handle 10 electrons. For suppose if it is gaining 5 electrons, so its protons are 5 protons only internally in the nucleus, but around the electrons are revolving in orbits, they become 10 electrons, which is not possible for boron nucleus to handle. So that is the reason they lose that electron to get a state of duplet stability. So metals, that is why we say metals will always lose the electron to become stable. So same way, always non-metals will gain electrons to become stable. So either it might be duplet state or octet state, we are not much thinking about it. Every atom will struggle to become stable. For first 5 elements, it is going to be 2 electrons in their shell, that is the first shell, K shell, but for other atoms it keep on changes. So either it may have 8 electrons in the valence shell, or they may either be different. So but their aim is to become 8 only in the valence shell. So that is how the difference between a metal and non-metal will classify the bonds into 2 different types. Yes, the next concept, the main thing. What is a bond? What is a bond? So bond is basically which keeps two metals, so a metal and a non-metal, or a non-metal and non-metal together. So friendship is a one type of bond, so which keeps two people together. So similar way in chemistry, a metal and a non-metal, if they are together, best example is sodium chloride. So if I am speaking about sodium and chloride, so between sodium and chloride there is a bond, that's why they are together. So if I am speaking about H2O, so 2 hydrogens and 1 oxygen, they are together. What is the reason? They have a bond between them. So there are different bonds are there. So we will study the bonds one by one. So types of bonds. So what are the types of bonds? Yes, if you know, please comment it. So bonds are 2 types mainly we will study. Still there are many types, but we are mainly focused on the basic things which we are supposed to learn. So one of it is ionic bond. So the another name for ionic bond is electrovalent bond. So first we will study what is ionic bond or electrovalent bond. So this type of bond will exist between a metal and non-metal. So ionic bond will exist between a metal and non-metal. That means definitely you require one metal and non-metal. So how does this work out, ionic bond? So first suppose if I take a metal X and a non-metal Y. We already know metals are meant for losing the electrons, non-metals are meant for gaining the electron. Whatever the electrons are lost by the metal are completely transferred to Y. It's completely is getting to Y. So we will study an example by explanation of sodium chloride. So if I am speaking about sodium chloride, metal is sodium, non-metal is chlorine. The atomic number of sodium is 11, the atomic number of chlorine is 17. What about the electronic configuration? The electronic configuration of sodium is going to be 2, 8, 1, whereas chlorine is 2, 8, 7. So we can clearly say it has 1 electron extra and chlorine has 1 electron deficiency. So what happens here is this electron will be completely transferred to the chlorine. How does it transfer? So sodium will lose 1 electron to become Na+. So we call it as sodium cation or formation of cation. Similar way, if we are speaking about chlorine, chlorine will gain 1 electron to become Cl-. So this is called as anion. So now both of these ions, whatever it is formed, sodium will combine, sodium cation and chlorine anion will combine to form sodium chloride. The bond that exists between this type of formation of compounds, we call it as ionic bonding or electrovalent bonding. Along with that, you need to study one thing. Electrovalency. What is electrovalency? It's very important concept for class 10th ICSE students. So electrovalency is nothing but number of electrons are transferred from a metal to non-metal during a formation of electrovalent bond. So here from sodium to chlorine, how many electrons are transferred? One electron is transferred. So the electrovalency of sodium chloride, what is the word? It is called electrovalency. So the electrovalency of sodium chloride formation of compound is 1. One electron is transferred from sodium to chlorine. So this is what is all about ionic bonding. So let's move to the next concept. It's going to be covalent compound. So what is a covalent compound? Okay, it's very simple. Ionic compound, we have studied that complete transfer of electron has taken place. In covalent bond, it is not going to be transfer. It is going to be the sharing of electron. But the difference is what you are supposed to know here is, in ionic bond, one metal and one non-metal is involved. Whereas in covalent bond, both of them are non-metals only. The bond between two non-metals. So we call that type of bonding as covalent bonding. But here there is no transfer. The mutual sharing will take place between two atoms. So we will study with an example. Now, if we take the molecule CH4, we know the carbon has atomic number 6. The electronic configuration is going to be 2, 4. Hydrogen atomic number is 1 and electronic configuration is also going to be 1. So this is a basic electronic configuration. So now carbon require 4 more electrons to become stable. So we have a famous dot structure. The name is called as Lewis dot structure. What is this Lewis dot structure? So it is the representation of valence electrons around a symbol of an atom. Now, if you take methane, carbon is there. So if we are applying Lewis dot structure, how many valence electrons are there in for carbon? 4 are there. So when we represent 4 dots around the electron, that doesn't mean it is a total number of electrons. It just says about the valence electron. So carbon has 4 electrons, so C has 4 dots. That is known as Lewis dot structure. For hydrogen, how to represent Lewis dot structure? It has 1 electron only. That is only going to be the valence electron. So hydrogen, if we can represent just dot, that is going to be the Lewis dot structure. See, it can be written like this, or sometimes we can also represent the X as a symbol for electron. So now we will study the how does this covalent bond will work out. So carbon has 4 dots. Now each hydrogen has 4 electrons. Each hydrogen has 1 electron. So 4 hydrogens will have 4 electrons. So this hydrogen will share this 1 electron with carbon, and carbon will share this 1 electron with hydrogen. So this becomes the common region for carbon, showing carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its region. Similarly, the common region for hydrogen having 1, 2, so duplet state of stability. For carbon, octet state of stability. So this is how mutual sharing of electrons will take place between carbon and hydrogen. So we call that type of bonding as covalent bonding. Same way, number of electrons are shared between each atom. That speaks about covalency. Electrovalency was about number of electrons transferred. Covalency is all about is number of electrons are shared mutually between two atoms. So this is what about a covalent bond. So I hope you have understood the difference between ionic bond and covalent bond. So ionic bond is formed due to the complete transfer of electron, whereas covalent bond is formed due to the mutual sharing of electrons between two non-metals. So this is what is all about this covalent and ionic bonding. My dear friends, definitely watch this video completely. So if you have any doubts, we will be clearing in your next videos which you are going to observe in our channel. So Keep watching us. Let's study in the next class about carbon and its compounds, which will be useful for the all class grade 10th CBSE students as well as 9th ICSE and 10th ICSE students. So let's watch in the next video with a chapter called carbon, or also called as organic chemistry. So take care. Bye bye.